Hello everyone, and welcome to this science tutor video for CSEC physics on the topic of graphing. So a graph is, as you can see on the screen, a method used to visually represent collected data. Alright? A graph usually shows you how one physical quantity or one parameter varies with another parameter. And it's a visual method, which means that it's the presentation of the data, or the presentation of this collected data, is plotted in a way that usually makes it easy for you to see without necessarily doing plenty of calculations. You can see how one quantity varies with another quantity. So your typical graph has two lines at right angles to each other that are referred to as axes. You have your x-axis, which is horizontal, your y-axis, which is vertical. And so the two quantities that you want to investigate are plotted, one on the x-axis and one on the y-axis. Alright? These quantities can be anything. So in other words, you might be investigating how the passage of time, which goes on your x-axis, affects the temperature of a body or the temperature of a system, which goes on your y-axis. Now usually the quantity that changes, or the one that you have physical control over, or the one which moves forwards by itself, or the one that is independent of any physical interaction or physical control, is plotted on your x-axis. Right? This is referred to as the independent or controlling variable. It's referred to as a controlling variable because it's this variable, the one that's plotted on your x-axis, that determines what happens to the variable you plot on your y-axis. The y-axis variable is referred to as the dependent or controlled variable. Alright? And so in many cases you will measure a certain interval, or take some measurements for your independent variable, your x-axis variable, and see what happens to your y-axis variable for those same measurements. Once you've collected that data, you can plot it on your graph. And the actual graph that you get depends on what the relationship between x and y is. So if you're measuring the temperature of a system as it changes with time, you might get a straight line, meaning that as time increases, the temperature of the system increases. Right? You might get a straight line with a constant value, which means that there is no change in temperature even as time increases. You might get a curve, or you might get a pattern that fluctuates with time. The important thing is that the graph shows you how temperature changes with time. Now, there are some essentials that you're expected to have on every graph that you plot. Yeah? And this applies outside of CSEC physics. In general, every graph is supposed to have a clear title. Right? The title should tell you concisely what is being plotted on the graph. So in other words, the title might be something like pressure of a closed system versus time. What this tells you is that the pressure of the system is being plotted on your y-axis, and you're investigating how the pressure of the system varies with time, which is plotted on your x-axis. Generally, the quantity that comes before the versus is the quantity that is plotted on your y-axis. The one that comes afterwards is plotted on your x-axis. The next essential that you're expected to have is a scale. Right? Now the scale of your graph just tells the reader what the value of each division on the graph paper is in terms of the units that you're using. So if, to get all of the data you've collected on your graph, the one division and each division is usually a centimeter long or 2 centimeters long. If 1 centimeter is worth 2 seconds, or has a value of 2 seconds, then it means that you have a scale on whichever axis this is of 1 centimeter to 2 seconds. If this was on your x-axis scale, then it means your x-axis is always represented by a scale of 1 centimeter to 2 seconds. So any 1 centimeter division along your x-axis has a value of 2 seconds. Right? And you're expected to have a scale both for your x-axis and for your y-axis. Right? So you're expected to have a clear title. You're expected to have a scale. You are also expected to have clear axes. Now remember we said the axes are just the vertical and horizontal lines on which you plot your data. Right? So these axes are supposed to be labeled with whichever quantity is being plotted on them. So for instance, if we're plotting the temperature of a system against the time that's passed while we take this measurement interval, on your x-axis you'd expect to have your scale 1, 2, 3, 4, 5, 6 seconds, etc. Instead of writing the unit that you measure your time in after each one of these numbers, what we do is to write the unit under the axis, alright? And label the axis with the quantity being measured. So I'm measuring time. The time is being measured in units of seconds. This is what we refer to as a clearly labeled axis. If you don't have the unit, we don't know what system or what your measurements are being taken with respect to. If you don't tell us that time is being measured on this axis, then we have absolutely nothing to compare it to. So your axes must be clearly labeled, both the x and y axes. And then the last thing that your graph must have is points. Alright? Because a graph without data has no meaning. Now at this level you're expected to plot the points in one of two ways. Alright? You can either plot your points, indicate where the exact point is located on your graph paper by a dot inside of a circle, or an x, a small x. Right? These should not be too large, because if they're too large it's difficult to see where exactly the point is. If they're too small, then it's difficult again to determine where the exact location of the point is. So they should be reasonably sized. Also make sure that you stick with one or the other when you're plotting your graph. So don't start off with dots and then move to crosses. Alright, so in our next video we'll go through some of the data that you can get from a graph, and we'll actually do an example with a plotted graph and analyze some data from it. Alright, so thanks for watching this video. Stay tuned for the next one.